this is our last video involving scientific notation. In this case, we're going to be adding and subtracting them. This also tends to be the most difficult. However, it's not, as long as you're remembering the rules and following the steps. So, for adding and subtracting, let's review from the previous video. If you end up having to move a decimal to the right, that means your exponent has to be dropped. It works vice versa, because for this lesson, we're going to be changing the value of our exponent, which means you're going to be moving the decimal. Again, if your exponent goes up, then that means you'd have to move your decimal to the left. So, 3 things that you need to know. First, order of magnitude, or the exponent, must be equal before adding or subtracting them. So that means that both pieces that you're adding or subtracting need to have the same exponent before you do anything else. So you're going to have to rewrite one of those notations. Second, you're then going to add or subtract the coefficient depending on what the problem's telling you to do, and you're going to keep that common power of 10 that you found from that first thing. And finally, you're going to then rewrite it in proper form if necessary. Sometimes it's already written with your 1 value in front of your decimal place. Sometimes you'll have to rewrite it depending on which piece you change first. So, I have example 1a because I'm going to use this problem twice. Once with changing the 7 to a 9, and then with changing the 9 to a 7, so that you can see that it doesn't matter which one you choose, you're going to get the same answer as long as you follow the rules. So, if I'm going to increase 10 to the 7th times 10 to the 9th, that means I have to move my decimal place to the left of that first value. So when I move it 2 places to the left, because I have to increase it by 2, my new form is going to be 0.03 times 10 to the 9th, because I moved my decimal, which means my exponent increased, plus 5 times 10 to the 9th. So now, I'm going to add those coefficients, the 0.03 and the 5, and keep my times 10 to the 9th. So now when I rewrite it, I have 5.03 times 10 to the 9th. And as you can see, this is already in correct scientific notation because I have a single non-zero digit in front of my decimal place. Like I had said before, if we use that same example, 3 times 10 to the 7th plus 5 times 10 to the 9th, only now I'm going to drop this exponent of 9 down to a 7. So the first parenthesis I'm not going to touch for right now, but when I change the second parenthesis, if I'm decreasing my decimal place, or my exponent, my decimal has to move to the right. So when I rewrite it, I get 3 times 10 to the 7th, nothing changed there, plus 500 times 10 to the 7th, because I had to move it 2 places to the right. So again, I'm going to add my coefficients and keep that common power that I just created. So I would end up with 503 times 10 to the 7th. This time, I'm going to have to rewrite it because I know that I need 1 non-zero digit in front of my decimal. Since 503 doesn't have a decimal present, I can put one at the end. And when I put one at the end, I need to move it 2 places to the left. When I move my decimal to the left, that means I have to increase my exponent. So since I moved it twice, I have to add 2 to the exponent, and I get 5.03 times 10 to the 9th. Same concept for when we do subtraction. I only worked this problem out once, but again, you could choose either way to rewrite it. If I have 2 times 10 to the negative 3rd, and I'm subtracting 8 times 10 to the negative 4th. So again, in this case, I'm going to increase from a negative 4 to a negative 3, which means I have to add 1. So when I rewrite this, I have 2 times 10 to the negative third, subtract 0.8 times 10 to the negative third. I'm going to subtract my coefficients and keep that times 10 to the negative third value. When I subtract them, 2 minus 0.8 is going to give me 1.2 times 10 to the negative third. We know that this is correct scientific notation because I have one non-zero digit in front of my decimal place, so I don't need to rewrite anything.